We are talking today with Ben Devane, who is in the College of Education. Ben, remind me of your area.
I'm in learning educational psychology and learning sciences.
Great, thank you.
Yeah.
And then with Juan Pablo Hourcade, or JP, as some of us like to enjoy calling him. Thank you. And JP, you are in, I'll just
in computer science.
Computer science. And
Yeah.
I've had the pleasure of working with JP in the past because he has been a Obermann Fellow in Residence, and I believe he's been on our advisory board and various other things. So thank you both for being here today. And we're going to explore some issues around technology and learning, and particularly for K-12 and even for younger kids, I think, in many instances of this conversation. And also, it was just shared with me that, Ben, you have an undergraduate degree in computer science, right?
Yeah. I'm a computer scientist from back in the day. So, and have since moved to. Well, I don't know if I've really moved away that much, but yeah.
Okay. Well, I think that's good. I think that's an interesting context to the conversation. So that's
Mhm.
the reason I wanted to highlight it. So why don't you start, Ben, by talking about what your research is kind of broadly, and then focusing in on a specific project you've been doing more recently.
Sure. So my research broadly investigates playful learning and learning around games. Both in what we call formal settings, so like schools, and also informal settings like community centers, museums, libraries, etc. And my work often focuses on kind of creative, collaborative learning with around games and play. Um, um, and often looks at kind of social aspects of learning around games of play. Specifically what I'm doing right now, so I'm working with collaborators at the Iowa Children's Museum and the University of Washington, and we have an exhibit that we've kind of jointly designed. This is a project that's funded by the National Science Foundation called and it's an exhibit that has to deal with skate park physics. So we're interested in providing kids age 4 to 8 or 3 to 8 and their families with an experience of real world physics and their bodies in motion, basically. And the kind of concept of the skate park physics exhibit is that kids can engage in a lot of tinkering and experimenting activities around the physics of skate parks, whether that means adjusting wheel size on a skateboard, experimenting with friction of different surfaces, or using blocks to design your own kind of ramps and jumps and things. My specific kind of I've we've been very collaborative between the three groups, but my specific part looks at has been uh, driving and directing kind of the development of a large a skate park physics game where you can design and play through your own skate park on a large 48-inch tabletop. It's kind of part Tony Hawk, part Excite Bike with a little bit more physics added in. And what we hope with this game, it's kind of like a large flat iPad with a wall-mounted display as well. And what we really want to see is the game was designed both to allow kids to tinker with physics and tinker with skate park design, and also we wanted to foster collaborative play. So this is a really great surface for multiple people to work on something at the same time. And we also wanted to understand kind of how adults and children, families, play together, and we call that intergenerational play. It doesn't just have to be parents and children, but we're really interested how adults can help children learn, and even vice versa.
Mm-hmm.
Yeah.
One question was somebody kind of bringing in the physics part, and then you were bringing in like your knowledge about building these kind of educational games.
Yeah, so we collaborated with a couple of people in science education, Mark, that had consulted for us, Mark McDermott, and John Duncase, and they, they both have rich history in science education, and we were building off basically standards for kids at the kind of K-2 level, focusing more on experiences and less on kind of them walking away from a museum with kind of robust content knowledge.
Mm-hmm.
That makes sense.
Mm-hmm. And so then, since the pandemic hit, you've worked to move this online, and
Right, yeah. So
looked
we've
at it.
moved the
Yeah.
game online now. It's on the Iowa Children's Museum website. You can go under the Notion of Motion exhibit, which is the name of the exhibit, and you can play it there. You can play a version of it there. It's not quite fully functional, and we're further thinking about ways we can have teaching and joint activities that we can create around the game, like kind of just like using blocks to create a ramp or something of that nature that people can do at home, and especially young children can do at home. So we're trying to think about that part. It's not up there yet.
Mm-hmm.
We're trying to think about how we create an extended or connected museum experience.
Mm-hmm. Yeah, that's great. And I'll put the URL, the link in the notes.
Oh, thanks.
For the show. So yeah,
Thank you.
yeah. And so I love the notion of intergenerational learning, and let's just put a kind of pin in that, because I think that we'll come back to that through some of our other discussion here. But JP, could you tell us about some of your work, again, at kind of a broad scale, and then more specifically what you've been working on recently and how you're understanding what's been happening in these last 2 to 3 months through that work?
Sure. Thanks, Jennifer. So let's see. So my area of research is human-computer interaction. So this is basically about making people central to the design of computer technologies. And within that area, my research has been mostly about working with groups of people who tend not to be the focus for Silicon Valley. So I've done a lot of research with children, with older adults, with people with specific medical conditions, people with disabilities. But I would say at least half of the research has been with children. And a lot of it has been, first of all, putting children in a central role in the design of technology. So really, as opposed to the adults coming up with all the ideas and then just have children test them, we really try to engage children in the design of technologies, and they really guide a lot of what we do. And most of the work with kids has been, at the very least, around 2 themes, and adding a third one more recently. And those 2 themes have been creativity and collaboration. So if I look back at most of my projects, they've involved some form of those 2 things. And it's in part an acknowledgement that a lot of the engagement with technology that children have does not involve those 2 things. Sometimes it tends to be a little more passive consumption of media that's very individual. And so, with a lot of my research, I've been looking at helping kids be creative, have control over what happens with in their interactions with technology, and involve activities that help have them engage with others, be it other children or adults. And the third part that I've been in a little more recently, and this is in my latest research with preschoolers, has been also that these activities with technologies involve direct connections with the physical environment around them. So not just being stuck with a technology, but get you to move around the room, do things, have physical interactions with objects that are not technological. And the project that we've been working on more recently, we call it Story Carnival. And it involves children participating in make-believe play activities where they pretend to be characters in stories, and they play with each other and with physical props with the support of adults and some technologies that we developed. And the the idea behind these activities is that they've been a very particular kind of make-believe play activity has been, or I guess there's significant evidence that it helps children develop executive functions like self-regulation, planning, etc. So we have been doing research at a local preschool for the last couple of years. Our last set of sessions were in the fall, and now we had to, for obvious reasons, stop doing that research. But it makes me think also about how, with the switching of kids staying at home, some of those basic ideas that we're trying to pursue, the creativity, collaboration and communication with others, and the connection with the physical environment, what's happening to those? And in particular, concern about the social interactions, obviously.
Sorry, I'm realizing I muted myself. Was some of the impetus for this research in this piece out of concern or data suggesting that kids are spending more time online and don't have that kind of real life interaction?
That is a good question. So there's some of that. So if we go back to the about 10 years ago, that's when a lot of households started getting smartphones, then started getting tablet computers. And these mobile touchscreen user interfaces significantly lowered the barriers to access computers for young children. So before that, you wanted to use a computer, by and large, you had to use a keyboard and mouse. And that posed some significant barriers, especially for children under the age of 4. So even if, even if some kids could use computers by age 3 or 4, it was not the most enjoyable experience. So not a lot of it was happening. And then what happened is everybody started getting smartphones and apps. At the same time, the American Academy of Pediatrics was saying no screen time for younger children, or very limited screen time, right? And what happened then is a lot of researchers who designed technologies for children stayed away from the younger ages in designing technology, because I can't say as a computer scientist to a parent, don't listen to your pediatrician. I'm a computer scientist. Let's try this out with, try the software with your children. But then what happened is all the commercial developers put up thousands of apps, and kids started using them. And all of a sudden we have children spending a significant amount of time with these devices, and we don't have any research to understand what are beneficial uses, what are non-beneficial uses. If we're going to have kids use these devices or use technology more, how can we make it something where we have some confidence that it's going to have benefits to them? So that's where some of the ideas for the project came from. What we started looking at it was, well, maybe let's find out what positive we can do. And then the next part was, let's find out what skills are often a challenge for that age group for many children. And we run into the executive functions as being a set of skills that are very important, that are developed, go through critical development stage at ages 3 and 4. And that a lot of teachers report that when kids get to kindergarten, they don't have those skills, and they get in the way of kids doing well in school.
Yeah. Then
we found out what are some of the best evidence-based ways to enhance executive functions, and that's in why aren't they being used more? And so we try to design this technology to lower barrier to those activities.
I think that one thing that I find exciting about the work of Juan Pablo and his students is, like I'll just go back, and you probably know the history better than me, but I think 15, 20 years ago in the kind of cultural milieu, kind of there's a broader social conception of technology as a separable space, if that makes sense, a separate or separable space. where you go to a virtual world and it's completely different than your real life, or you go to a game and it kind of isolates you from everybody else. And I think that what you see in kind of cutting edge research like in computer science, like Juan Pablo's around, especially with children, is you're actually um, taking technology and making it part of everyday life, where it's much more outward facing, and it's speaking to them like a fictional character, and assuming the role of almost another puppet, I guess, in play. And it's really exciting stuff.
And I think that actually moves into one of our questions. I'm going to kind of reverse us just a little, but certainly, for quite a long time now, you're alluding, Juan Pablo, to going back, 10 years when all of these devices were really, landing in our homes. And now that everybody's just home, this concern about, how much is appropriate. You alluded to the American Pediatric Society. And so we were talking about, kind of different kinds of tech and figuring out what is appropriate and how do you gauge that. And I think you both have really wonderful responses to that, if you can just reflect.
Sure. Do you want to go first, or shall I?
I could go in this. I might know a little bit more about this than I do, but I would say that first thing to think that comes to mind is television, because that's kind of a long-standing debate that was going on long before tablets and smartphones. And well, from what we know, because there's been a lot of studies on it, it's not just about how much TV time, but what shows kids watch and how they watch, and they're watching with a parent, are they commenting and reflecting on what's going on as they watch, or is it just kind of entertainment with no additional value? So there's been studies that have shown that certain kinds of children's television help kids develop their vocabulary, other kinds do the opposite, right? So so it's the kind of, it is what media you experience, how you experience it, right? And obviously the how long can play a role too, but it's about the whole context of the experience, not just the amount of time.
Yeah, so I think that the kind of history of research on screen time kind of dates back to television, as you said, and it was a time before kind of people were thinking about both television and television programs more broadly, but also thinking about computing devices not just as kind of transmission media, but also devices that you can use for creating things, or for socializing and getting together with and meeting up with friends and those sorts of things. So like Juan Pablo, I would I would say that I see much more the nature of how much time children spend with devices, the nature of the time that children spend with devices, as much more important than the extent of the time, if that makes sense. So if they're doing something like creating or remixing or programming, or writing a story on the computer, or rewriting a story on the computer, or hanging out with friends in a healthy and productive way on the computer, then I don't view that as much of a problem. If you spend 3 hours a day, say on a video chat with your your grandmother who you can't see, is that really a bad thing for a young person to experience? Is that bad screen time? Or is that productive kind of connection with somebody that they might have, they might miss emotionally in the midst of the pandemic? So.
Mm-hmm. Mm-hmm. And you gave those three kind of examples of like.
Oh right, yeah. Oh right,
Yeah,
yes.
that I'm
So,
very fond of.
oh
So.
yeah, no. There's a report that was funded by the MacArthur Foundation looking at how kids engage with digital media, and it talked about kind of three ways that they do is hanging out. So that can often be just And I think that you've spoken about your son playing video games with his friends in the midst of pandemic, and how that becomes a kind of social space for them, where they can just kind of hang out and chat about everything ranging from politics to friends to whatever. Hanging out, geeking out, and messing around. So geeking out might be where you're really engaged with investigating some aspect of media, where you're investigating how to design 3D art, or you're thinking about how you can tell an interactive story, an interactive fiction story, using scripting, and messing around is where you're, remixing, trying out new things, and kind of trying to master a new domain with technology. Um, you know, again, working with digital media and technology isn't kind of an end in and of itself, but when you do productive things in these kind of three ways, like hanging out where you're
Mm-hmm.
engaging in healthy kind of social connections, where you're geeking out, where you're teaching yourself, where you're teaching and mastering really difficult things, or messing around where you're experimenting with a new thing that you haven't encountered before, those can be pretty productive and healthy things to do for kids.
Mm-hmm. I think
I
it would
mean,
be interesting. I mean, since we're all parents and we have somewhat different age or kids, of reflections on those. So like one thing that's coming to mind as you give that example, Ben, is there was a game a few years ago. I can't remember the name of it, that my son loved, and it was a history game, and it had all sorts of shooting and stuff as well. It wasn't like some like wonderful clean cut history game, but it was basically about World War I. And he
mhm,
figured out a way to redo it where you could completely change the outcome of war. Like you could put,
mhm,
like, all of a sudden Iran and Guatemala were like major players in World War I.
yeah,
Now what? And so that would be like the
mhm.
messing around.
Messing around kind of thing,
Yeah.
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 Trying out new things and experimenting.
Yeah.
There's a rich history of that with historical simulation games, where people try to think about, different historical phenomena and outcomes, and how things might change, how wars might be prevented, those sorts of things.
Mm-hmm.
And like I know there's a Peloton, which is Civilization University, which is like a fan-run university on the Civilization game series, is one instance of that,
Mm-hmm. Mm-hmm.
quote unquote university.
Yeah. Yeah.
Yeah, and notice all those examples, they involve thinking, right, and being creative, and forms of communication. And the communication doesn't have to be constant, but it might be that you make something that then or that obviously the child makes something that then they want to share with others, right?
Mm-hmm. Mm-hmm.
And so it may not be that it's constant communication or collaboration all the time, but that there's eventually at the end some goal of a social
Yeah.
outcome.
Yeah.
Um,
Definitely.
right.
Yeah. So even though I know this isn't something that, or I don't sense it's something that is central to either of your work, I think you definitely know more than many of us. So I would, if you would entertain us with helping us understand the infrastructure of getting schools and entire districts into this sort of online learning method. And I know that there was some frustration this spring, like, why aren't we doing some of these things faster? And and I also patience and kindness. I don't want to say everybody was just ticked off, but some of it is that many of us don't understand what's involved. And so if you could just weigh in on that, that'd be great.
Yeah,
Yeah, go ahead. You first.
I guess I can start a little bit. So um, it's a lot more complicated than you think. I guess that's the place where we start, and there's a lot of things that make it difficult, right? So if it were just a matter of purchasing hardware and then getting it out there to people, that would be relatively simple. Even that can be a little complicated, right? There's infrastructural issues, obviously, just even with making sure everyone gets access to the internet. That's still on the relatively simpler side. More complicated infrastructure issues have to do with being able to repair devices, providing technical support. That starts getting more difficult. So I know with places that have done implementation that takes a few years to get right, oftentimes. But perhaps the biggest challenges are that for most of the computing systems that have been pushed out, if we go back to perhaps some of the better known ones with the One Laptop Per Child initiative about 15 years ago, they have been top-down approaches where there's a few people who decide we're going to put this kind of hardware and this together with this software tools. And they might be really interesting and kids might be able to learn with those, but oftentimes they don't necessarily align with the curriculum that teachers are supposed to be teaching or they're required to be teaching. And they don't necessarily align well with the way teachers are trained or how they know to teach, right? And from a human-computer interaction perspective, the main reason for this is that, again, this is a top-down approach as opposed to saying, how can we design technologies to support these teachers and these children in this context learn better, right? So that's one part of it. The other part is even at this point in this juncture, if you had some of those well-designed technologies, which by and large don't exist for supporting in-classroom learning. In some cases they do, but it's just not something that's where I could say, yes, this platform, this design follow that bottom-up approach. Now we're switching to learning remotely, right, which is a very different type of setup. So you think if you had classroom learning, you might set things up so kids can help each other out or collaborate, take advantage of the fact that they're all together, take advantage of other things that might be available in the classroom. All of a sudden, all of that is gone, right? So it's almost, even if you had good tools, good technology to use in the classroom to support learning, all of a sudden we're in a very different environment. So making it work well, and making it work well for the wide diversity of settings that children are going to see at home is very challenging.
Yeah, so I think that that you hit on several points there. I think, one major issue from the teacher's perspective is integration of technology, mastery of technology, using technology to teach, mastery of a new pedagogy that's technology informed and using that to teach, and bring that to bear on content knowledge. And that's not like a trivial task. If I was just thinking about like a algebra or pre-algebra class. A lot of those classes often use the whiteboard or chalkboard to manipulate representations, algebraic representations in real time, right? And when you are now given a PowerPoint, or you're not given a 2-camera setup, or something of that nature, you as a math teacher, you now have to figure out a whole new way to be able to show students how to manipulate algebraic expressions in real time, and a whole new way to teach that, if that makes sense. So, crossing out X's, those sorts of things. And so it becomes a whole new task that you're doing, and a whole new way of teaching that you have to do. And, going back, there's a tremendous infrastructure that has to support this. I mean, even if a student has internet access, which not all students do, having good internet access so that you can do 3 or 4 or 6 hours of Zoom a day and not be charged $200 a month, or more, might not be there. And so, schools, I know the Iowa City school districts had to distribute Wi-Fi hotspots and devices and tablets. And, Juan Pablo mentioned, I think when we spoke before, about, families might not have enough devices for all the kids to attend class, or enough spaces for them to attend class simultaneously. And so it's a very challenging problem for school districts and for teachers, and also for parents and students.
Mm-hmm.
I
So
think
I want to, go ahead.
Well, the other point we were mentioning last time, and maybe this is what Jennifer was going to bring up right now, is the disparate impacts, right? So if you have homes where it's what Ben was alluding to now also, where there's more space, there's high quality internet, high speed internet access. There's parents with some level of computer literacy, so they can troubleshoot any issues. Or say if a one of the children needs to print out a worksheet, it's probably a lot easier to do it on paper than sometimes than trying to copy off of the screen and doing it in another way, right? So I think there's a lot of small things that can make a big difference. Because sometimes even with, speaking of our own children, with my own son, sometimes it's just a question that takes 10 seconds to explain, right? So it's not something that requires a big time investment, but if you get someone in the home who can answer that question, makes things easier. Otherwise, they might be stuck on that for who knows how long.
Right. So I want to kind of transition to the end of the conversation and ask you each with a little bit of brevity, because we've been talking for a while, though it's been awesome, but is to thinking ahead toward next academic year, and with the presumption right now that a lot of people are giving that there will be more periods like we're experiencing now, of these periods of extended maybe being a month, maybe 3 months of learning remotely, of what you see as a possible maybe possibilities on an exciting side, like, wow, this could actually be an opportunity now that we know this is going to happen for X to occur. And then also things that you think we need to really be aware of some challenges, even though you just touched on a few. So Ben, would you mind starting?
Yeah, so I mean, I think that we have a kind of opportunity now. It's an opportunity that's going to require a lot of time investment and things like that, but an opportunity to rethink how we teach with technology, rethink using technology as a medium for information transmission, which is kind of how we do it now. We think about kind of stuffing facts and concepts into a learner's head, and think about it more as a way to help people experience, investigate, and do meaningful things that align with 21st century skills. So it could be doing collaborative writing, writing fan fiction from your favorite kind of young adult novel. It could be sharing stories and doing peer critique, or sharing with large audiences and doing peer critique. It could be doing a kind of an investigation of a scientific issue in your area, ranging from water quality to soil yield to economic segregation, economic and racial segregation, patterns in a city. There's all sorts of ways that you can use math and science inquiry and things like that to do really exciting and meaningful things. And so that's a big ask for teachers who are, having tremendous burdens placed on them right now. But at the same time, I think just starting to think about that sort of thing will be important for the future of learning with technology.
All right. So maybe I'll start with a negative so I can finish with a positive. How about that? We can do it that way. So I think the one area of concern is neurodiverse children with disabilities, and all the time that they would have had at school with all the best services available. Whereas at home, it's going to vary significantly, but oftentimes parents may not have the time or even the education to be able to provide the same level of services that children were getting at school. And I think, if anything, I will hope that they're a priority for being able to be at school with the right services, and I think that could be done. On the well, slightly less negative, maybe, I think it's going to be a big challenge this coming academic year, and I think I wouldn't get my hopes up terribly high for the average experience that students are going to have. However, also necessity is the mother of invention, right? So it's going to be an opportunity for a lot of innovation, and we're very likely to have some breakthroughs around, I guess, maybe in part in the US, we have the blessing and curse of having so many school districts around the country and many different ways of doing things. So we might run into some disasters and some distinctive successes too. And I think we can learn from those, but hopefully there will be some room for teachers, for other innovators to do some interesting work and to put it out there and to try it out in case we're very likely we'll have at least some form of online instruction this coming academic year.
And
So it's a positive. I'm hoping that we'll come up with some cool new innovations.
And then it's up to the two of you and your various colleagues, both at the University of Iowa and around the country, to be studying and sharing those successes. And so I look forward to hearing about them, because I trust there's going to be some breakthroughs. I really do. Yeah.
We'll do our best.
You guys, thank you so much. It was, I learned a lot, and it was really a pleasure.
Well, thank you so much for your time. Yeah, thank you.
Yeah.
Thank you for doing this Pandemic Insights series.
Yeah, it's been fun. Thank you.